The TwinPlex microphone is by far the most complex condenser mic we've ever built.
At Shure, we've been developing microphones for more than 92 years. But this time it took a whole different way of thinking about how to make a microphone so small and so precise.
We have an entirely new facility at Shure dedicated to TwinPlex. Every process had to be invented in order to make this product possible.
We ended up finding the absolute right balance between handcrafted precision and automated manufacturing.
A traditional microphone has one element in it. We decided to try and squeeze as much microphone in the same amount of space. So we flipped our microphones on the side, and we actually have a dual diaphragm design with 2 parallel diaphragms. And this allows us to have the best-in-class specifications, gives us bigger low-frequency response, smoother top-end response. These are the best-sounding lavaliers and headsets you've ever heard.
We spent a whole year talking with customers about this product and what they really wanted out of it. We knew it wasn't going to be easy, but innovative products never are.
Our first prototypes were frankly too big. We took them out in the market and they said, sounds awesome, but way too big. I'll never put that on anybody, ever. So we went back to the drawing board and said, how do we take out 3 to 4 millimeters of length? The solution was put the PCB, the electronics of the mic, in between the 2 diaphragms instead of outside. So we were dialing in our sound quality and we were getting our size down. We were getting ready to do alpha testing, sending out really early samples and get some market feedback. They couldn't believe how small the mic was, yet how big the sound was. Our next challenge was sweat resistance.
We wanted a way to mimic our customer's environment, and we took the theater as a prime example for sweat outs. So we knew that we needed a really repeatable, controlled process to be able to measure what was happening with actual sweat in our products. So we developed this thing called the SweatBot.
We rest lavalier microphones on a heated moleskin pad, and it mimics a forehead. It drips artificial sweat into the element and allows us to catch microphones failing red-handed. And we tear it open and we figure out how it's failing and we make it better. An integral part of the TwinPlex microphone is the frequency response caps. And it's kind of a first line of defense for sweat. Through about 10 different iterations, we finally arrived on the one that works the best. It is a micro-molded plastic cap that is nano-coated with a super hydrophobic coating and offers 10 times longer the sweat out performance than the uncoated version.
The number one failure with lavs is cables. It's really difficult to create a cable that is flexible and thin and yet really reliable.
Cables get abused in the audio industry. They get yanked, painted, tugged on, ripped through clothing. We needed a cable that the industry has never seen before.
We paid as much attention to the engineering of the cable as we did the microphone. It was that important.
We wanted to bring medical grade cables into the audio world. The TwinPlex cable uses a double helix construction that's wrapped around 2 tinsels, and these tinsels serve as a redundant ground. All of this is wrapped in an ultra thin paintable jacket that resists cracking, that doesn't dry out, and is ultra flexible. Our cable flex machines at Shure are designed to break cable. The TwinPlex cable performs 100 times longer on our flex machine than anything else we tested. This cable is simply the thinnest, most durable cable the audio industry has ever seen.
The culture of innovation is really what drives us at Shure. It's part of our DNA to be thinking about the next solution that we need to be developing. And that's what results in products like TwinPlex.
We did not take the easy way out on this one. We redesigned, refined, tweaked, modified, so that you can trust it on the biggest stages you have.